This session we will focus on another feature of this object-oriented programming, that is polymorphism. Actually, the word polymorphism came from two different Greek words. Poly means many and morphism means form. So polymorphism is actually use of a single type entity, can be either method, operator or object, to represent different types in different scenarios. So same entity, maybe operator, object or method, which act differently according to different situations. Just for example, we are already familiar with the one type of polymorphic operator, plus. Here we can see that depending on the type of operand, it work differently, it function differently. Just for example, here we are giving two different integer number 1 and number 2 as operands for this plus operator. So it will simply perform the addition, arithmetic addition will be performed by this plus operator. Whereas for the same plus operator, here we are providing two different strings. str1 is hi and str2 is how are you. And applying this plus operator, this plus will act as a concatenation operation. That's the difference. So the same operator, same plus operator perform addition in one scenario, whereas concatenation in another scenario. So that is example for polymorphism. And also we are familiar with the length function, right? To find the length of or the number of items in a sequence. So if you are applying the length operator or length method with a string as the operand, it will count the number of characters and it will return the number of characters. Whereas if you apply the same length method with a list, it will count the number of items present in the list, right? Not the characters. So depending on the type of argument or type of operand, this length method work differently. So that's also an example for function polymorphism. So we have seen this operator polymorphism, function polymorphism, and polymorphism is available in a class also. That is, Python allows different classes to have methods with the same name. So depending on the class, the corresponding method will perform differently. That is also an example for polymorphism. You will see. Let us see an example for this class polymorphism. So we have two different classes. One is tomato and the second one is apple. Inside the tomato, we have two different methods. One is type and the second one is color. Inside the type method, we simply print vegetable. In case of color, it simply print red. So coming to the definition of apple class, there also we have two different methods with the same name. You can see that type is there and color is also there. Okay, with the same number of arguments, only self is argument. And here in case of apple, it will simply print fruit and the color again simply print red. Okay, so the two different methods in two different classes with the same name. Now let us see how it actually invoked. And we are defining a new function in which one argument is there, and the purpose of this function is whatever object we are passing, corresponding object's type method will be invoked and the corresponding object's color method will be invoked. So depending on the argument we are passing, appropriate type and color methods will be invoked. Now let us invoke this class by creating objects. First object is created, obj tomato, by invoking the corresponding constructor tomato. So an object for the tomato class is created with the name object tomato. And another object apple, is created from apple class. Okay, now we are invoking this function by passing this object tomato as argument. Its corresponding methods will be invoked. So inside this, it will call these two different functions, right? Yeah, function object tomato as argument, it will come here and the type will be invoked first. So this will be printed, vegetable will be printed, then color will be invoked, this red will be printed. Again we are invoking the same with the second object as the argument, right? Object apple as argument. In that case, this type will be invoked first, then this color will be invoked. So fruit and red will be printed in that case. So depending on the object to which this method is applied, corresponding method will be invoked. So this is an example for class polymorphism. Now let us see this polymorphism together with inheritance. As you know, inheritance is a feature by which a child class can inherit the method defined in the superclass or parent class, right? Yeah, as such, the definition can be used by the child class. That is inheritance. Okay, so inheritance, the child class inherits the method from the parent class, and we can modify a method in a child class which was inherited from the parent. Okay, so child class, after inheriting a method defined by the parent class, this child can modify it. The definition can be modified by the child, and that is called, actually, that is re-implementation of a method in the child class. It is called method overriding. Okay, so we will see how that can be done. Here's an example. We have a class called shape. Inside that we have a init method, simply assigning a argument passed in the at the time of object creation into this attribute name. Okay, and another method area, which is simply an interface here, does nothing, right? Pass means simply does nothing, but it's an executable statement. So if we have some definition in which we are not implementing the corresponding method here, but leaving such implementation to some other class, in that case simply put pass statement here. Okay, that, so we have only the interface here, no executable statements other than the pass. And another function fact returns a string. I am a two-dimensional shape, that is the function of this fact. And another method str, which returns the name of this particular class. Okay, simply returns the attribute name. So these are the different methods. And now we have another class square, in which shape is a parent class. So all the methods and attributes of the shape will be inherited by this square. Now inside the square we have its own init method in a constructor with one argument, that is length, and what we are defining here is super.init square. So we are invoking the super. Super init means the parent's init definition. This is the definition inside the parent, right? Super means its parents corresponding methods that we are invoking here, and providing argument as square. So the argument here is name, so that value is square. Okay, and self.length is equal to length. So what we are doing here, so that also will be invoked here inside the child's init method. First we are invoking the corresponding init method of the parent by passing square as the argument value. So name will be assigned the value square. So self.name will be square. So that is the first attribute for the child class. And the second attribute, that is a length attribute, that will be assigned to its length value. So two different attributes are there for the child class square. Those are name and length, whereas for the shape only one attribute is there, that is name. Okay, so this is the functionality of init. So inside init we are invoking the corresponding parents init also to assign the name value, and for length it is explicitly writing another statement. And for area, so you can see that inside the shape we have a function or method called area, right? We are not defining anything here, simply passing. But here we are returning self.length square. Okay, so redefining the area within the parent class, that is done here. Okay, and the third method is also there, fact, that's also there in case of shape, whereas in case of square it simply return this statement: squares have each angle equal to 90 degree. So each and every method which are defined in the case of shape are redefined in the case of this square child class, right? So that is an example for method overriding.